Okay, continuing on with section 9.1, part 1, for example number 6. We need to find the end points of the minor and major axis for the graph of the ellipse x minus 3 squared over 25 and y minus 7 squared over 64 equals 1. So we need to figure out the highest point on the major axis, lowest point on the major axis, the rightmost point on the minor, leftmost on the minor, and the highest focal point and the lowest focal point. So let's do, well, we don't really have to sketch it. Let's see if we can do it without sketching it. Important information that we need to list. We need to list the center, which is at 3, 7. And then we need to know where our major axis and minor axis are going from. So biggest number is underneath y. So that means this is going to be a vertical ellipse. So 64 is the same as 8 squared. So to find the major axis, the highest point on the major axis and the lowest point on the major axis, we're going to have to add 8 and subtract 8 to 7. Since it's underneath the y, it's going to affect the y point of our center. So our highest point is going to be 7 plus 8, 3. The point 3, 7 minus 8, is going to be the lowest point on the major axis. So now let's figure those out. We would have 3, 15, and then 3, negative 1. Okay. Now the rightmost and the leftmost point is going to be on our y-axis. So that is going to be here in the x part. Did I say y? X-axis. It's going to be on the x part of our equation, and it's going to affect the x point of the center. So the rightmost point is going to be when we add 5 to 3, and the leftmost point would be when we subtract 5 from 3. So we're going to have the point 3 plus 5, and then y stays the same, and then 3 minus 5, and then the y stays the same. So 8, 7, and the point negative 2, 7. Okay, now we need to know what C is. To find our focal points, we need to know C. So remember we said we need to take our longest point, which in this case is going to be 64, and so a squared, which in this case 64 is going to be that, is equal to the sum of the other two. So 25 plus c squared. So let's put in a squared, so 64 is equal to 25 plus c squared, so 20, 60, 40, 39, so c squared is going to equal 39, and then c is going to equal the square root of 39. So now to find where our focal points are, the focal points are always going to be on our major axis, which is going to be on the y in this case. So it's going to affect the y points of our center. So our highest focal point is going to be at 3, and then 7 plus the square root of 39, and then the point 3 and 7 minus the square root of 39. Now if we were going to graph those, we would definitely want to figure out what an estimation of the square root of 39 was, and then add that and actually subtract that from 7 so that we could graph it. But I do believe that MyOpenMath will accept that there for an answer. Okay, so I did skip one example that I thought was pretty easy. And I'm not going to go through every single one of these examples because, yeah, I think you guys should get it by now pretty quick. So our center on this one is going to be the point 3, 2. And then we're going to go 2 points in the x direction. So a distance of 2 to the left and a distance of 2 to the right. And the distance of 1 up and down. So this is a horizontal ellipse. Okay. And that's all for number 8. So let's go down to example number 9. So given the ellipse x squared over 64 and plus y squared over 100 equals 1, list the coordinates of the foci. So we just need to know what C is. This is centered at 0, 0, so the foci are going to be a different distance of plus and minus C, because our center is at 0, 0. So we need to know which direction that's going to be in. So the foci are always going to be on the major axis. Major axis is going to be the y-axis. And so we're going to have our equation a squared equals b squared plus c squared. A squared in this case is our biggest number, which is 100 equals 64 plus c squared. So subtract 64 from both sides. That's going to be 36. And so 36 equals c squared, which gives you a value of c equals plus or minus 6. So now we need to know what the coordinates are from that. Our center are at 0, 0. And so y is going to be affected by our c. Our foci is going to be on the y-axis. So we're going to have 0, 6, and 0, negative 6 for our foci points. All right, example 11. So skipped a couple again. So write the equation of the ellipse that has a center at 1, 2, foci at negative 3, 2, and a vertex at 6, 2. So what do we notice about all of these? All of these have a 2 in common. So that is important to note, because if our center is at 1, 2, and our focus point is also at 2, this tells me, and our vertex, this tells me that my major axis is y. So major axis is y. It also tells me that this is a main vertex, not a co-vertice, but an actual main vertex. So from all of this information that they give me, I should be able to figure out what C is, because C is the distance from the center to the foci. I should be able to figure out what A is, because A is the distance between the center and the vertex. And then I can use my equation, a squared equals b squared, is a squared equals b squared plus c squared. Yep. Because a squared is the longest, yeah. And yeah, so let's figure out what those are. Then we can figure out b from there, and then we'll have enough information to write our equation. So from the center to the foci, we're going from 1, 2 to negative 3. That's going to be a distance of 4 units. Okay, so the 2 stays the same, so that means we're staying on that 2 line for y. Ooh. No, I should have graphed these, huh? If our y stays the same and it's our x's that are changing, ooh, that means that our major axis is the x-axis. Good thinking. Okay. So we have, I was trying to do this without graphing it, but I'm a very visual person. I should have maybe graphed it first. So, center at 1, 2, and I have to visualize it all. Negative 3, 2, yep. And that's still a distance of 4. So C is equal to 4. Okay. And then our vertex is at 6, 2. Well, our center is at 1, 2. So to go from the point 1, 2 to the point 6, 2, that's another 5, that's 5 units. So that means A equals 5. Okay, that means this is going to be a 3, 4, 5. But we'll go ahead and fill this out anyway. So A squared would be 25. C squared is going to equal 16. So 9 is going to be equal to B squared, and B is going to be equal to 3. Okay, so we have our center. We also know what A is. We also know what B is. So since we know all of that information, we can go ahead and write our equation. It is important to know which one is the major axis. I would have got it wrong if I would have stuck with Y being our major axis. But it is indeed X that is our major axis. So we have X minus 1 squared over, this is our major axis, so that's going to be A, So a squared, which is 25, plus y minus 2 squared over b squared, which is 9. And that equals 1. And then that is our final example, our final answer for example. Okay, this is going to be the last example that we do for this section, for part 1. So write the equation of the ellipse that has center at 1, -4, vertex at -5, -4, and covertex at 1, -9. So since our center and our vertex both have a y value of -4, that means that it is solid on the y-axis, but it's moving in the x direction. Okay, so our major axis is going to be the x-axis. And so our biggest value, or a, is going to be in this format. So x minus 1 squared over a squared plus y plus 4 squared over b squared equals 1. And so now we have to figure out what a and what b is. And so from the center, 1, -4, to -5, -4, that's going to be a difference of 6 units, and you can graph that if you need to. But we're going to have 1 on the right-hand side of the y-axis, and then count 5 more to the left-hand side. So that's going to give us 6 units for the vertex. That means A is going to equal 6, because that's the different distance between the center and the vertex. And then B is going to be the distance from the center to the co-vertex. And so we will have, from -4 to -9 is going to be a distance of 5 units. And so we have x minus 1 squared over 36 plus y plus 4 squared over 25 equals 1. And that's all for section 9.1, part 1.